Okay, so this flip book, you'll have to forgive my screen up here. It's missing the giant Pythagorean Theorem title over here to the left. But this is the front of your flip book. This is page 70 in your notebook. It is called the Pythagorean Theorem. It is named after a guy called Pythagoras, hence the name. And it's a very important theorem. Remember, theorem just means something that is true and can be easily proven. It is something that is used in all future math classes. Okay? We're going to make sure you understand it today before we even start diving into the trig part. We're just doing Pythagorean Theorem today. The first thing you need to understand is if you have a triangle that is a right triangle, first of all, what does that mean? That means there's a 90-degree angle in it, which is what this little square represents. And let's say you have sides A and B, which we call legs because they make the right angle. We've talked about this. The legs of a triangle, of a right triangle, make the right angle, just like the capital letter L has a 90-degree angle in it. And then the hypotenuse is always opposite. I want you to take your pencil, and you're going to hear me say this all week long into next week, okay? I want you to correctly identify the hypotenuse of a right triangle, and I have a trick for it. It involves drawing an arrow from the right angle to the hypotenuse. So you go to your right triangle, find the right angle, see more. Draw an arrow to the side farthest away, not touching it. That's your hypotenuse every time, okay? It's really important that you always label the hypotenuse correctly or you're going to get this wrong. Now, what I want you to take with your highlighter and highlight is the formula for the Pythagorean Theorem. You're gonna need to memorize it. I'm gonna give it to you probably. I might give it to you for the quiz, but then by the test, you need to have it memorized because it's one of those things that's so important and gets used so much. I want it like second nature in your mind. Okay. Here's the formula. It's a squared plus b squared equals c squared. A, B, and C come from the sides. I'm trying to highlight the letters here too. Comes from the sides of the right triangle. What letter do you notice is the hypotenuse?
C.
And that is every single time. Every single time. Now, what's the purpose of the Pythagorean Theorem? Why is it so important? Why is it so helpful? If you've got a right triangle in front of you, and you need to know all the side lengths, and you're missing one of them, there is a relationship, Pythagoras figured out, there's a relationship between the three sides of a right triangle that holds true every time. And that is, if you take the two legs, square them and add them up, you get the exact same value as if you take the hypotenuse and square it, which is what the formula means. Take the legs, square them, add it up, you'll get the same number as the hypotenuse squared. So what's the purpose of the Pythagorean Theorem? We can use it to solve for a missing side of a right triangle. That's the purpose. Now, you can only use it, there's two restrictions. Number one, it has to be a right triangle. Number two, you have to know at least two sides. Because if I gave you a triangle and I said this is x, this is y, and this is 4, and I said solve it with the Pythagorean Theorem, you would have to be like, I can't. I need like, no, 90 has nothing to do with it. 90 is the equal. We're talking about the side lengths. So imagine like a ruler. So we're not talking about degrees. If I gave you a triangle like this, and I said find A, you should say can't, because it's not a right triangle. Notice there's no right triangle there. It's just a regular triangle. So the restriction is with the Pythagorean theorem, has to be a right triangle, and we need to have at least two sides. Okay? Now, if, enter new vocabulary, Pythagorean triple, if we have, say, three sides of a right triangle, three numbers, that when we plug it into the Pythagorean theorem, they make a true statement, it means that they form a right triangle. Okay? So, for instance, if I have a triangle, you don't have to draw this. If this was 3 and this is 4 and this is 5, watch how I plug it in. You would label the hypotenuse. So my hypotenuse is C. So plugging it in, I would have 3 squared plus 4 squared equals 5 squared. What's 3 squared, y'all? 9. What's 4 squared? And what's 5 squared? What's 9 plus 16? 25. So do you see how this is a true statement? So because this plugged into the Pythagorean theorem makes a true statement, it means that these three numbers come from a right triangle. That makes sense? Here's another set of numbers. We said 3, 4, 5. What if we had 5, 12, and 13? All right, watch it. So 5 squared plus 12 squared equals 13 squared. What's 5 squared? 25. What's 12 squared? What's 13 squared? 169. 144 plus 25. 169. So you get a true statement yet again, which means the numbers 5, 12, and 13 are coming from a right triangle. Now, if I was to stand here and do this again with these numbers and these numbers, we would still get true statements. That's because they're called Pythagorean triples. A Pythagorean triple means, hold on, it means numbers that if I plug them into the Pythagorean theorem, it makes a true statement, okay? Now it says, what are some more? Well, we're just going to fill in this chart. Let me show you some more. And I'm not asking you to memorize these. In fact, I would like you to take your highlighter. This is the one you should have memorized. 3, 4, 5 is the one that makes life so much easier if you have that memorized. It's called a 3, 4, 5 triangle. And it comes from a right triangle. Now, 5, 12, 13 comes up every now and then, but I'm not going to expect you to memorize that. Now, it says, what are some more? Well, to get the next line, all you would do is multiply everything by 2. So a 3, 4, 5, if it were doubled, would be a 6, 8, 10 triangle, which would also be a Pythagorean triple. Now, this is going to get crowded. This would be a 10, 24, 26. So if we double this, we would have 16, 30, 34. I'm just doubling the numbers up above it. These are just dilations of it, right? If we double this, we would have 14, 48, 50. So to get the next row, you could double those, but those numbers would really get crazy. So to get the next row, you're going to now times 3. You're going to triple it. So we're just going to triple those original numbers. So a 3, 4, 5 times 3 would be a 9, 12, 15. Right? 5, 12, 13 times 3 would be a 15, 36, 39. Ben, are you writing any of this down?
I was actually just participating online.
An 8, 15, 17 tripled would be a 24, 45, 51. And then a 7, 24, 25 would be a 21, 72, 75. So what we've done right now is we've covered the new stuff. Now we're going to open up the flip book and practice it, and then I'm going to give you your practice sheet, which is the grade.
So this is trig? Easy.
Well, we haven't hit trig yet. This is this is the introduction to trig. Okay, so open your flip book. The first thing we're going to do is we're going to practice finding the missing side of a right triangle. So look at this first example right here. The first thing I want you to do is to draw your arrow from the right angle to the hypotenuse, which in this case would be C, right? Now we're going to set up the formula. Let's copy it first. Don't write big, y'all. A squared plus B squared equals C squared. Does it matter how I plug the legs in? No, because they're just getting squared and added together. So order does not matter with the A and the B. What does matter, and will give you the wrong answer if you mess it up, is what letter? C. It matters. C is always the hypotenuse. So when I plug this in, I've got 3 squared plus 6 squared equals, I'm finding C. All right, so now it's a basic equation we need to solve for C. Go to your calculator, enter the 3 squared plus 6 squared. If you can't do that in your head, let me pull my calculator up. 3 squared plus 6 squared.
Hey, who is that? They disappeared. Hello?
No.
What up,
Tuesday. Okay, so this might be take that out. And I have something else.
I covered you.
All right, pull your calculator up, and I'm going to enter 3, the squared button's right here, by the way. Squared plus 6 squared. Oh, it didn't. I forgot the plus sign. 3 squared plus 6 squared. I thought I hit the plus sign. I must have hit equals. And you get 45. Hold on. Okay, so right here I'm going to rewrite 3 squared plus 6 squared is 45 equals C squared. How do you undo something that's squared? You square root it. So we're going to square root both sides. Now here's where something from Algebra 1 is coming up, and I know you've slept since then. When I type the square root of 45 in my calculator, I get a decimal. From Algebra 1, you should remember how to break down square roots. It all revolves around perfect squares. So let me give you a crash course. Go to the bottom of your notebook paper, not the flip book. We're going to put it at the bottom of the notebook paper. Let's refresh your memory. You might not want it on the back though.
I'll put it on the back.
Or go to the top of your notebook paper, somewhere on your notebook paper so that you can see it. Let's refresh your memory on what's called your perfect squares. Yes, it goes a little higher, but yeah. You should know this. We went over this. Your perfect squares are numbers that come from multiplying something times itself. So the smallest perfect square is 1 because it comes from 1 times 1. So it's also the most boring one because nothing happens. So 1 is the smallest perfect square. Now count. 2 times 2 is 4. Keep going until you hit 15 times 15, and then write that. So make your list right now of your first 15 perfect squares. And you get it by simply counting. 1 squared, 2 squared, 3 squared, 4 squared. See where I'm going with this? Keep going. If you need your calculator, use it. Go all the way up to 15. Then, do it. Uh-huh. Mm-hmm. Go all the way up to 15 times 15. I need you to make this list. I don't want you just writing it after I write it. It's going to do you no good.
Yeah, Ben, come on. What are you doing?
Glue stick, Shelby. Glue the flip book to notebook paper. You're going all the way up to 15 times 15. Okay, now here's your crash course. You can put this on the back of your notebook paper if you want, or wherever you have room. So I'm going to make a note. Recall, because you've already learned this. You learned this last year, and you practiced it last year. I know it's been a while. So if I said to you, what's the square root of 8, and you typed it in your calculator, you're going to get a decimal. I don't want a decimal. I want what's called simplest radical form, which means I need you to break this down as far as it'll go before decimals. It's like the factor tree. Do y'all remember the factor tree in middle school? Like if I give you a number, say it's 15 is boring. If I gave you a number like 18, you would say, oh, 2 goes into that 9 times, and then 9 is 3 times 3, and then you're done. So the factor tree is 2 times 3 times 3 will give you 18. Remember that? Kind of? Okay. It's the same concept, but it's actually easier because we are not going to keep going and going and going. The idea is we're going to do it one time. We're going to break this apart into just 2 numbers. One of the numbers comes from the list. Y'all listen? This list. One of your numbers comes from this list. Every time. Every time. What number from that list will go into 8? 4 goes. You want to write it first. So this becomes the square root of 4 times the square root of 2. because 4 times 2 is 8. And then what is the square root of 4? 2. And if you don't know that, 1, look at your list. What order is it in? It's in position 2. So that was 2 squared. Or 2, type it in the calculator. The square root of 4 is 2. So this becomes 2 square root 2. Does this ring a bell from Algebra 1? Okay, this is what we're doing now. This is really important. So now I'm going to go back to the flip book and we're going to break down 45. Okay? So I'm actually going to leave the list right here. So we're breaking down 45. How do you break down a number, maybe that you're not quickly familiar with what goes in it? Let me show you. You visualize on your list where that number would fall in order. 45 would fall here, right? Y'all with me? And then you check the numbers to the left. You check them going this way. So you go to your calculator, and it's a guess and check game. You say, 45 divide, what's the first number? 36. You should know that's not going to work, but divide it anyways. 45 divide 36. If you get a decimal, it means it didn't go. Move to the next number. So we're going to repeat. 45 divide 25. Decimal. Doesn't work. Go to the next number. 45 divides 16. Decimal. Doesn't work. Go to the next number. 45 divide 9. Ding, 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 ding. That tells you, okay, rewrite the 45 as 9 times 5. So this becomes square root 9, square root 5. Please tell me I. Yes, okay, good. And then the goal is the number that was in the list keeps going. What is the square root of 9? 3. So this becomes 3. So the square root of 40, it's just the wind. The square root of 45 is 3 square root 5. Now, how do you know if you did this right or not? This is a beautiful thing. You go to your calculator and watch this. You type, here's how you type square root, by the way. You have to hit second, and then it's the squared button, 45, and you leave it. Then you type the answer you came to, which was 3 square root 5, and you leave it, and you compare those decimals, and that's how you know if you did it right. Okay? All right, I'm going to flip back to the front to write this down on the flip book, and now we're going to do the next problem. So we were right here. We broke this into square root 9 and square root 5. Square root of 9 is 3. So we found C to be 3 square root 5. All right, let's do the next one. Draw an arrow from the right angle to the hypotenuse. Plug everything into the Pythagorean Theorem. This is an A right here, so that's your variable. So we have A squared plus 5 squared equals square root 43 squared. Now this one's, probably you might think this one's more challenging because you have the square root of 43 as one of the side lengths. But you still go about it the exact same way. Now, over here in the previous problem, I was able to type this in the calculator, right? I can't do this here because my variable is now one of the legs, not the hypotenuse. So we need to clean this up. What is 5 squared? Okay, and then what is the square root of 43 squared? What happens there? It's just 43. So if you don't know how to simplify this in your head, these cancel, by the way, but if you don't know that, let's say you forgot, you would just go to your calculator and you would type exactly what you see. I see the square root of 43. Now you do have to come out of it. You have to arrow out right there, and then you're going to hit squared. Hit enter, and it's going to show you that it's just 43. As ugly as that is, those two operations cancel. Caleb, stay with me. They cancel. So this just becomes 43. So what started really ugly actually ends up being not bad. Now we do need to move to 25 over by subtraction underneath. So we're going to subtract the 25 to the right. So a squared equals 18. How do we undo squared? We square root. So we're going to square root both sides. This is where you go to your list of perfect squares, and we need to break it down. Kind of already did this one, but let's pretend like we hadn't done it yet. So you would think to yourself, now the smaller numbers you can probably do in your head, but you would think to yourself, what perfect square will go into 18? What number from your list goes into 18? And the answer is 9. How many times? Goes 9 times 2. And what is the square root of 9? So A is 3 square root 2. It's an 8. Isaac, you writing this down or are you sleeping?
I'm sleeping.
Can you take your sunglasses off?
Oh, yeah.
Please.
My bad.
Let's do the next one. Draw an arrow to the hypotenuse so you know where that number gets plugged in. Set it up. So we're going to have 10 squared plus b squared equals 12 squared. I do that, but I'm going to go ahead and square it. So I'm going to square these numbers so I know what they are. So this is 100 plus b squared equals 144. What do I need to do? Minus the 100. So b squared equals 44. Now what? Square root. Then if you aren't going to participate, you need to sit in your desk.
I got you.
The couch is for,
Participated.
well, privilege. It's if you're not working, then I don't want you comfortable.
I was actually.
What number from your list of perfect squares goes into 44? 4 goes. How many times?
11.
11 times. So we're going to break this into square root 4 and square root 11. And what is the square root of 4, y'all? So b is 2 square root 11. All right, let's do the last example. Looks really ugly. Just set it up. You know where your hypotenuse is. So we've got, now I would put it in parentheses since there's a lot going on here. We've got 2 square root 3. All of that's getting squared, right? The square root will cancel the square. Sorry, the square will cancel that square root, but that 2 will get doubled, like squared. I'll show you in a second. All right, and then we've got square root 5 squared equals c squared. So as ugly as this looks, when you go to write it down, you could go to your calculator and just type the whole thing in as long as you've typed it correctly. And then I'll show you why it is this number. So parentheses 2 square root, no. Parentheses 2 square root 3. Come out of the square root, you've got to arrow out of it. Close parentheses squared plus parentheses square root 5, come out of it, close parentheses squared. Now let me explain to you why that's the number. I'll show it to you over here on a bigger screen. It was 2 square root 3 squared plus
Wait, what'd you get again?
17.
Okay.
Alright, so look at it. Here's why that's the number. What does squared mean? It's multiplying by itself, right? So if you need to visualize, look at this. This is 2 square root 3 times 2 square root 3, right? That's what that means. So what's 2 times 2? 4. What's the square root of 3 times the square root of 3? Square root of 9, which is what, y'all? And so what's that? 12. You see how that comes about? Now your calculator does that for you, but I'm explaining how it comes about. And then here, of course, those cancel, and this is 5. So 12 plus 5 is 17. That's why it comes to 17. So right here, we're going to write that we get 17. Now, we have to square root both sides, right? Square root. So, we have to break 17 down. Go to your list of perfect squares. 1's the only one that works. So listen, hold on. Is 1 going to change anything?
So it's 17?
So you leave, it's square root 17. So you leave it as the square root of 17. So sometimes you can't go anywhere with it, which as ugly as it looks are actually the more desired problems because then you're done. Okay, so that was practicing using the Pythagorean Theorem to find a missing side with both pretty numbers, radicals, and ugly numbers. Okay? Come down to the bottom section. Now I'm going to throw all 3 numbers at you, and I want you to tell me, could these numbers be the side lengths of a right triangle? The way to determine that is first, you mark which one would have to be C. How do I know which one that is, y'all? It's always the longest side. Okay? So in this right here, 4, 7, 11, clearly this is C. Then you plug all 3 of them into the Pythagorean Theorem. So I'm going to write a squared plus b squared equals c squared here. Doesn't matter how you plug the 4 and the 7 in. What matters is the 11 has to be in place of c. And then now you check the left with the right. So you would go to your calculator and type 4 squared plus 7 squared. You get 65. Then you would type 11 squared. And you get 121.
So no.
Does 65 equal 121? No. So the answer is no. Those 3 side numbers, like links, could not describe a right triangle. All right, let's do 21, 72, 75. Which one has to be C? 75. Plug it in. So 21 squared plus 72 squared equals 75 squared.
Yes.
What's the left become?
5,625.
The shower.
There's not a lot of work to show. I need to see this. What's the right become?
5,625.
So do they equal?
Yeah.
Yep. So then the answer is yes. Those 3 numbers could describe the length of a right triangle.
No, what about the next?
Now, well, what about the next one? When you first look at it, you need to know what the square root of 10 is before you dictate what C has to be. So go to your calculator, type the square root of 10, so you can get an idea of what that is as a decimal. Well, it will be, but we need to know what C is. In this case, I just needed to verify that the square root of 10 is not possibly bigger than 24, which you should know that it's not. It can't be. But if you're just not good with numbers, then just type it in. Square root of 10 is 3 point something, which tells me, okay, 24 is my C. So we're going to plug it in. A squared plus B squared equals C squared. Right here? That doesn't mean number 3. No, I'm sorry. That doesn't mean number 3. It means that's the side that measures 3. Alright, type the left in your calculator. 3 squared plus square root 10. Come out of it. Squared. What do you get? You get 19. Then type the right side in.
No.
Does 19 equal 576?
No.
Absolutely not. So the answer is no. Alright, look at the next one. That is side 9, side 2 root 10, and side 11. 2 root 10, let's see what that is as a decimal so we know what the measurement is. Okay, 2 root 10 is 6 something. So what's C? C is going to be 11. Plug it in. So you got 9 squared plus 2 root 10 squared equals 11 squared. So 9 squared plus, I'm going to put it in parentheses, 2 square root 10. Come out of it, close the parentheses, and square it. That's important. If you don't put it in parentheses, it will only square the root 10. It won't square the 2, and you're going to get the wrong answer. Okay? So when there's a coefficient in front of the radical there, put it in parentheses so it will actually square everything. So you get 121. So 121 equals, and then 11 squared is also 121. Now, there's a lot of word problems involved with Pythagorean Theorem and trig. The good news is every single one of them involves what shape being drawn? A right triangle. Look at this. Did you know that televisions are measured by the diagonal on the TV screen, not the horizontal or the vertical? It's always by the diagonal. Okay? So look at this right here. If the diagonal of the TV is 52 inches and the width is 40, what's the height of the TV? So here's a picture. Is yours saying that? Or is it not? Yeah. So here's a picture. We have a diagonal, and they told us it measures what? 52. I'm going to draw a right angle right here. It says that the width is 40. It says, what is the height? So this is a standard Pythagorean Theorem problem. I want you to try it. It is exactly like the top of this screen. Plug it in, and in this case, we are going to go to decimal because we're talking about actual measure. Plug it in and tell me what decimal you get to the nearest 10. Y'all should be doing this if you haven't. Evan, have you done it? What number goes in place of C? 52. Please try it, y'all. Please try it. If you're just copying down what I put on the board, that means you're not practicing it, which means you're going to get it wrong come quiz and test.
That's true. I did the thing after that, and I got 33.22. I see what you. Oh.
Now,
Thank you.
no, because we're talking about like actual measurement, it's safe to go to a decimal. I would never expect you to break down 1104. Now listen, here's what we need to do. I realize it's towards the end of class. You are not packing up yet. Let me make that clear. I'm going to give you this sheet, which is page 71.
Where am I going with this?
To the back. I'm going to give you this sheet, it's page 71. Then I want you to find a partner, and if you can't find one, I'm going to pick one for you. Find a partner and designate which column you're going to answer. So find a partner and assign the columns to who, like I'm going to do A, you do B. And then you have 10 practice problems to complete, and you're going to check your answers with your partners at the beginning of class tomorrow. We should have the same answer. Now listen, it does come to the same answer after you round. Okay, so it's not the same answer at first, it's when you round at the end to get the same answer. You with me? It says, and let me look at my answer key. I think we went to the nearest 10th. Stand by, I'll tell you. You could go ahead and start working on a few. This is your practice assignment that I'm going to be checking for tomorrow.
I played a show last night till like 2.
What did you do A?
Yes, sir.
So, number 1, you're going to the nearest 10th. Number 2 is a yes or no question. And then the remaining questions, it is telling you what to round to. If it's the nearest whole number or the nearest 10th. So pay attention to that, okay? This is your practice assignment. I'm taking a grade on it tomorrow.